Hello, I'm John Roberts. I'm a senior go-to-market database specialist. I'm joined today with Ian. He's also a go-to-market database specialist to cover Amazon Aurora ML. So you may be familiar with Amazon Aurora, especially Postgres, and the capabilities of storing vectors inside the Postgres database and be able to index that and search on that. But you may not be familiar with the capabilities associated with interacting with machine learning models in Amazon Bedrock, or even how that actually works. And so today we're going to show you how you can leverage SQL and Amazon Bedrock to really kind of create generative AI applications and be able to kind of bridge the gap between what you may know already in SQL programming language and what's capable or possible with the large language models that are found that are available in Amazon Bedrock. So with that, I'm going to give this over to Ian to let him kick off the presentation.
Thank you, John. John already introduced myself, but just want to give you my name is Ayan Majumdar. I'm a go-to-market solution architect at AWS, supporting FSI and TMAX segment. I'm based in Minneapolis, and now let me. John, are you able to see the screen, the deck?
Yeah, we can see it just fine.
Okay, awesome. So this is our agenda for today. So first we'll discuss about the Amazon Aurora and its key benefits. Then we'll discuss the Amazon Bedrock and how it works. We'll also discuss how we can do the data ingestion to the knowledge base for Amazon Bedrock. Next, we'll discuss about the Amazon Aurora ML and how it can integrate it with Amazon Bedrock. We'll also showcase this in the demo. So, and lastly, we have any Q&A sessions. Also, if you have any questions during this presentations, please feel free to drop them in the chat. Either me or John will answer those questions. Moving to the next slide. So what is Amazon Aurora? So Amazon Aurora is a fully managed relational database engine that is compatible with MySQL and the PostgreSQL. It provides powerful performance for intensive applications or the critical workload at the 1/10 the cost of the commercial database. So it's a cost effective. And Amazon Aurora also offers high availability, which allow you to build your applications with multi-AZ features and perform the cross-region applications. So the recovery time, you can say the less than a 1 minute or so in case of disaster. It's simple to use and the follows as a pay-as-you-go model. And Aurora also a decoupled storage and query processing. It maintains a 6 copies of data across 3 availability zone. So 2 in each availability zone, you can say, to protect against the availability zone failure. And it can promote any reader node to a writer node in case of failure. Amazon Aurora also has a self-healing feature, so it automatically detects and repair the data corruption and ensure your database remains highly available and reliable. It has a faster recovery capabilities, which allow you to allow the database to quickly resume the normal operations after a failure, and it ensures your applications continues to run smoothly. It's also support the elasticity, so it can quickly scale up or down depends on your workload demands without any disruptions or to your applications. So this is the other benefits we are getting with Amazon Aurora. In terms of backup, Amazon Aurora support automatic backups. So you will get a daily backup based on your backup window or the maintenance window, I would say. So it will back up your entire database instance and your transactional log, and you get to choose how long you want to keep your backup to be retained. So maximum is a 35 days, and to ensure a durability or availability, Aurora keeps the a multiple copies of your backup in each availability zone. So in case of one of the availability zone is failure, you can easily restore your database instance from the backup. And there is very minimum impact on the database performance during the backup. But there is also features also like a multi-AZ. So if you have a multi-AZ deployment, you have a very I would say the no IO suspension, because all the backups are taken from the standby instances, not from the active instances. So first, cross-account database cloning. So another features on the Amazon Aurora is a cross-account database cloning. So let's say when you create a clone on a Aurora database, it's a new Aurora database with a compute instance is created, but it's connect to the same underlying storage volume as the original database. So this process is not copying the data, it's repointing the same storage. And after the clone is created, any updates or deletes or any edit made on the original database are only visible to the original database. And any updates made to the clone database, those are only visible in the clone database. And the original database that was present at the time of the clone creation is still visible to the both the original database and the clone database. Typical use case, let's say if you want to test your application or on real production data instead of creating a synthetic test data, you can use these features. And once the testing is done, you can delete the clone database to save some cost. Additionally, this features is helpful. So if you want to do a like let's say the reorganize your database, if you want to run any additional like analytics workloads on your transactional database, or let's say you are want to save a in point in time snapshot for analysis without impacting the production system, that time you can use these features like cross account database cloning. Moving to the next slide. So Amazon Aurora 0 ATL integration. So why we need that? So customer across the industries today are looking to implement the like near real-time analysis in their transactional database. So a common pattern we have observed, like moving data from operational database to an analytics data warehousing, is normally we need to build a like a expensive and a custom ETL pipeline, extract transform load pipeline. And with Aurora Zero ETL integration with Amazon Redshift, you can bring together like the transactional data of Aurora with the analytics capabilities, and you do not have to maintain like a complex or like a expensive data pipeline to move the data from Amazon Aurora to Amazon Redshift. And you can also replicate the data from multiple Aurora database cluster into a same or new Amazon Redshift instance to derive like a holistic insight across many applications. And any updates made in the Aurora are automatically and continuously propagate to the Amazon Redshift. So you have always the most recent informations in real time. As you can see in the diagram, we have a couple of data sources, transactional applications, analytic applications. Data is coming to Amazon Aurora, and then using the Zero ETL integration, you can set up in the console or itself. It's like a few clicks, and then you can move the, or I would say the copy the data from Aurora to Redshift. And once the data is landed in Amazon Redshift, your analyst can do the analytics or create the visualization using Amazon Quick Sites also. Amazon Aurora also supports like a blue and green deployment, so it's allow the user to update the database while minimizing the risk and downtime. So you can see in the diagram we have a two environment. One is the blue environment, one is the green environment. Blue environment is the current production environment, and the green environment is a kind of staging environment that mirrors the production environment. So using this deployment, we can create a mirror copy of the current production environment. So the two environment we can keep in sync using the logical replication, and we can then make the changes to the database in the green environment without affecting the production environment. And once you done with the testing and good to go, then you can do the switch over from the the green environment can be switched over to be a become a new production environment. And this switchover typically takes less than 1 minute and does not require any application changes. So blue and green deployment can be used for variety tasks like upgrading the DB engine version, changing the database parameters, or making the schema changes. So next is Amazon Bedrock. So what is Amazon Bedrock? So it is also like a fully managed service that offers a choice of high performance foundational model from the leading AI companies like AI 21 Labs, Anthropic, Cohere, Meta, Stability AI, and Amazon. And that's help you to build and scale like a generative AI application in the easiest way. And you can access all these FMs using the single API, And you can also customize all this foundational model with your organization's data using the techniques such as fine tuning or repeatable augment generation or RAG models. So since Amazon Bedrock is a serverless, you do not have to manage any infrastructure. So you can just securely integrate and deploy your generative AI capabilities into your applications. Also, it provides like enterprise grade security and privacy. At how this Amazon Bedrock works. So let's say, as you can see in the diagram, you can use the Amazon Bedrock Playground option to experiment with the foundational model and select the like one of the best suits, like one of the model that best suits your requirement. And then you can fine tune this FN using the RAGs or retrieval augment generation technique and use it as, or you can use it as it is, whatever it's coming from the foundational model. Then you can send this your like prompt to the model using the Bedrock API, and then the receive the model response in your application. So it's a kind of four-step process how the Bedrock works. Now the knowledge base for the Amazon Bedrock, that is another like features come with the Amazon Bedrock. Many companies often use the retrieval augment generations to provide their foundational model with the latest proprietary informations. And this retrieval augment generation or RAGs involves to retrieve the data from companies' internal sources, and using that data, it will enhance the prompt given to the FMs or foundational models. And this helps you to create a more relevant and accurate response. And knowledge base for the Amazon Bedrock is a fully managed RAG capabilities. So this allows the companies to customize their the response of their foundational models by incorporating contextual and relevant data from the company's own data sources. And this knowledge base is for Amazon Bedrock is automate like end-to-end tracks workflow, including starting from ingestion, retrieval, prompts, augmentations. Like it's a like end-to-end process, and it eliminates the need for you to write a custom codes to integrate the data sources and manage queries. It also supports like built-in session context management for multi-turn conversation, like the conversation that involves more than just in one single questions and response. And all the informations retrieved from the knowledge base comes with the source citation to improve the transparency and minimize the hallucination. As you can see in the diagram, the user submit a queries and retrieve the similar informations from the knowledge base, and then the user prompt is augmented with the additional context from the knowledge base. And the prompt alongside the additional context is then sent to the model. We have a like a Anthropic Claude model, Amazon Titan text model, A21 Labs, all the models, foundational models. And then once you send that all the details to the foundational model, finally you will get the response back from the foundational model. So that's the step number 6. So this is like an end-to-end flow, like how the knowledge base for Amazon Bedrock works. But how you can ingest the data for the knowledge base. So data ingestion is an important role. So this is how you can create like end-to-end RAGs or workflow using the knowledge base for Amazon Bedrock. So first step, select the data sources. It can be S3 and it supports the incremental update. We have also our other 4 type of data sources in preview state. So web crawler. So if you have like a public website and you want to use that data source as a that public website, you can use that web crawler. It's also support Confluence, Salesforce, and SharePoint as a data source. And once you define the data source, you can convert those data into a text or and split it into a like a manageable piece which we called like chunks. And it can be a fixed chunks or the default chunk, and chunk and then convert it to the embedding using the selected model, like you can see the Amazon Titan or Cohere embedding models. um, then you can store this embedding in a vector stores. As of now, the default is OpenSearch serverless, but also if you have any existing vector stores like Pinecone, Redis, MongoDB, and Aurora PostgreSQL, that also you can use during the vector store options. So you can pick your model which you wish to use to create the embedding as well as the vector store for this embedding. Uh, this is an example like how the embedding works. So as you can see, we have a, like insurance domain specific data, and we can break this data into like elements that hold the individual meanings in a, and that process is called tokenization. That elements can be like a words, phrases, paragraph, or entire document, whatever makes sense for your use case. And you can take those elements and pass them to the LLMs to derive the or like numerical vectors. Essentially, these numerical vectors are the array of the numbers for each elements, and these vectors keep the elements with the related meaning close to each other in a multi-dimensional vector space, and this is called a vectorization. You can then store this vector or embedding in a vector store, which we discussed in the previous slide. And then the diagram also shows in the right hand side, as you can see, the auto insurance and the car insurance are symmetrically similar, so they are positioned closely to each other in the vector space. And when you perform the semantic search, it will include the semantically similar concept or context in that prompt. So that's all from my side. I think next topic will cover by John. John, over to you. John, you there?
Sorry, I was speaking on mute. So yeah, I got the screen taken over. Can you see the code? Okay.
Yes,
Yeah.
John.
Okay, great. So I like to see things in code, and so I, I think it helps me kind of makes things more concrete exactly how this actually works. And so I thought I'd start with a simple example of actually using Amazon Bedrock using Anthropic Claude model. Okay, so the way this works, let's see, is that you first provide a prompt for the large language model. So you say, please provide a summary of the following text, and you're passing in some sort of text value here. And the you have to do that, you have to take that text and actually create that the body has to be in the form of a JSON object. And so there are some things you have to provide in the JSON object, some elements there, like stop sequences, top P, top K, so forth. But that is then that prompt. So it could be any kind of text string, it could be like that insurance example, you know, it's detailing coverage or something on insurance. But that's what then is created is it's is used for the model to create embeddings. Or to create, in this case, create a summary. So using the model Anthropic Claude, it is saying I basically want to have a summary of the text that I provided. So uh, Amazon Bedrock is serverless, right? And so you don't have to create like an EC2 instance or virtual machine to install and run the large language model. We do it for you through Amazon Bedrock, so it makes it very easy to use. There's models not just from Amazon but also Anthropic, AI 21 Labs, Cohere, Meta, Mistral AI, and Stability AI. So it's not just the Amazon models that are available. And that's a growing number of models that are available from those companies. So what does that look like? So like I say, Python 3 summary, hello world. So I'm passing it to Anthropic Claude saying, give me a summary of this. And so it's telling me, yeah, this is a common phrase used for introductory or test message in computer programming, right? So, and it was the large language model output this, it is Anthropic Claude in this case. The other type of a common large language model output is our embeddings. And so we talked about that earlier, Ian did, and how exactly what that is. So it's basically creating numbers from text input, right? And that those numbers represent the meaning of the text input. So like, for instance, the embedding for orange will be similar or close in numbers to the word pear because those are similar things, even though the letters are, I mean, the very few letters are shared among those two different words. So it's not like a text string comparison, it's the meaning of the words. And these numbers are stored as vectors, and so like vector databases and vector stores are common ones. We just mentioned a whole bunch. And Postgres is one of those, and it just stores vectors inside the database. And the way the terminology used for this is dimensions, right? It's like an XY, like be two-dimensional, but this has most of these vectors have multiple, like hundreds or thousands of dimensions, and they're stored inside Postgres as like it looks like an array. So those would be like elements in an array, but they're in a vector. They're considered dimensions. Um, And then, so they're again used for RAG applications. And then databases can store, index, and query these vectors very efficiently. And in this demo, a little bit, it will show actually querying the vectors and how you can index that and improve performance. So this is the code that does the vector embeddings. You can see it. I'm very similar to the previous example, but this time I'm using Amazon Titan embeddings, where I am invoking that particular model, and you pass in a prompt. The prompt I'm using is again hello world, but it's in the embed script this time. And the Titan embeddings, it accepts up to 5 meg of input. And the output, this has been snipped, but it's 1,536 dimensions. So it's very rich in the number of dimensions, and so it can be very accurate at the comparison of that array or that vector with another vector from another string that you provide. And so we'll show in a minute how you could actually query data in the database to get to similarity comparisons of different vectors in your data. So the Aurora ML. So this is kind of the key, the glue that matches up Aurora, like Aurora Postgres, with Bedrock. It makes it simple for you to really integrate your SQL code, your SQL data with machine learning, whether it be Amazon Bedrock, SageMaker, or Comprehend. This demo will talk about just Bedrock, but you can interact with these tools all with familiar SQL. And so it gives you a great capabilities of interacting and creating machine learning kind of applications with familiar SQL and making it very quick and easy and all integrated with the security and governance that you'd expect from an AWS service. So the process for Amazon, or actually the demo here, we will invoke Amazon Bedrock models from Postgres. We'll query for the model input as well. Like you can use SQL to say I want selecting from particular columns and use those columns, that data, to actually be input to invoking the models. And then the output, those vectors you can store, or even summaries you can store inside Postgres. And with vectors, you can use PG Vector, which is an open source package that's available with Aurora Postgres to store and index this data inside of Aurora Postgres. Okay, so we'll move on to demo real quick, and say go here. Now, this is a recording of a workshop that we have available, and the workshop is freely available. You can use it in your own AWS account, or you can use it in a lab environment that you basically work with an account team to get that set up for you. And so the application uses EC2, Bedrock, Aurora Postgres, and a Streamlit application. And what it's doing is actually querying the web database, or a database that has movie data, so you can get movie suggestions based on your input and using vectors. So like I said, you can use this through your own AWS account, or if you want to use have a session with a workshop session we can provision the resources for you, and so that way you do not have to be using your own AWS account to do that. The first step here is setting up the Amazon Bedrock model access. And so we go to Amazon Bedrock in the console, and you request access to particular models. For the workshop here, we're using some Amazon Titan, and also Anthropic Claude. So you have to go to the model access, you enable specific models, and then you can get the Titan embeddings, which is like the vectors that we create. And this is all shown in the we could follow along very easily, right? But we will use the embeddings for the similarity comparisons, and then we'll use Claude to do summaries of like movie reviews. Okay. So this has been edited for time because the Amazon models will be request for access will be granted immediately. But for the Anthropic, the third party models, it takes a little bit of time. It may take up to 5 minutes. It says in progress there, but give it a couple of minutes or up to 5 minutes and it will be available. So I snipped that for this demo so that way we can just jump ahead and move on to the next part. The next part is what we will set up an EC2 instance. For the CloudFormation template has already created the EC2 instance for us, and so it's just a matter of going to EC2 and connecting to it. And it's pretty simple because I'm just using the console instead of an EC, like a terminal session. I'm just using the UI that's provided in the AWS console to connect to it. So it makes it very simple. And from here, we're now in the AWS or EC2 instance with a shell. So that's it on the EC2 part and also the Amazon Bedrock part, right? So let's get started actually with creating embeddings. So what we'll do first is we'll create a embed.py, like a Python script, very similar to what we showed earlier, where I am providing creating a client using the Boto 3 service or package within Python, and then create a runtime using the Bedrock runtime. And here, what I'm doing is using the model from Amazon Titan that I just enabled in my AWS account, and I'm asking for an embedding from that. So the point of this is I can pass in a string like hello world to get the actual embeddings. So that's the numerical representation of the word hello world. When I first saw that, it really kind of made a lot of sense to me. It's like, okay, now I get it. I'm changing these words into these numbers, and that can then do comparisons. So this next part, I'm actually going to download the database backup file and then restore it into Postgres. And it's a small database with movie data, like movies that are available from this movie database. So now I'm going to go into PSQL and create the PG vector extension, which is just vector, and then also AWS ML. AWS ML is the extension for Aurora ML, and the vector is one that's available for all Postgres, the PG vector extension. So this is some of the data. Like this is actually the ID number 11, which is a Star Wars movie. Shows the different columns, like an overview, the keywords, genre, so forth, right? It's all separate discrete columns. The credits is actually an array of like movie actors. So this query, just regular SQL, I'm taking it, I'm just creating a single column with all of that data to make it easier to pass as a prompt to go get embeddings, right? So it has the title and all that information regarding the movies. So I'm going to take that and pass that to my Python script for the embeddings. So go back out to my shell, pass that whole Star Wars, Princess Leia, so forth. And that's the numbers associated with creating an embedding using Amazon Titan, right? And so that's if you look at those last three numbers, here in a minute, we'll see those same three numbers again, but this time we're going to do it within the database. So this is the magic of Aurora ML. So I'm using AWS Bedrock schema.invoke model get embeddings. I'm passing in a model ID, the content type, JSON, and that same Star Wars input. And then I can now create that same embedding that I created earlier, that same SQL that I got from the SQL database. I'm going to pass that over to create the embeddings, but I'm doing it in the database rather than having to jump out of the database and running Python or interact external to the database. If you notice those last three numbers, I just did that so we show you that it's the same value because I'm passing the same input. Whether I do this within SQL or if I do it outside within like Python directly, because we're using the same Bedrock model, the Amazon Titan model here. So another thing you can do then is, let's update the database and let's add a vector data type to my movies table, right? So each movie will get its own embedding. So this, I put it in a stored procedure, make it simple for you kind of to encapsulate the logic, but it's a pretty straightforward a SQL statement, like it's that same SQL statement we did earlier, where I'm taking all the data from the columns and putting it into a single column for each movie. And I'm passing that string over to Bedrock for that select AWS Bedrock invoke model to get my embedding. And then I'm doing an update to the database to set the value for each embedding for each row. And just for commit control, after every 10 records, I throw a commit in there so that way you can move forward. So we can do this real quick for the Star Wars movie, number 11 again. It's calling that stored procedure. You can see it's like almost instantaneous, right? Run over to, it runs to Bedrock and then invokes that model and gets the result and stores that in the database. So now I'm going to do the same thing, but this is for all movies. And because my table is a little bit large, I edited it, removed, for time's sake here. So it did the entire table with all the records inside of it. So now I'm moving on to well, how do I query this? How do I optimize the performance and what does that look like? So what I'm gonna do next is actually put some timing on, so that way we can see the timing of different queries we execute. And let's first do this explain plan. So this is using the Euclidean distance. So these are, think of a multi-dimensional array or multi-dimensional vectors, right? So I'm going to create this embedding dynamically for the input text of lightsabers, right? So I'm looking for something that's similar to lightsabers and using the Euclidean distance. And this is an explain plan for that particular query. So it's doing a full table scan, the sequential scan on the movies table. And if I then execute the query, which is using that order by syntax to get the most similar to my lightsabers embedding, I can see the top 6 records here that Lego Star Wars is the number one most similar to the lightsabers query. And then fanboys looks like it's the last one. And it took 302 milliseconds to get that query result. Now, if I create an index on that particular column, that for Euclidean distance, that's what that vector L2 ops means. That is an index type that's only used for Euclidean distance operators. Then if I do that same explain plan again, you see that operator that greater than dash, less than dash greater than, that's the Euclidean distance operator. You can see now it's using the Euclidean distance index scan, and the query performance is greatly enhanced. So before it was 300 milliseconds, and now it's going to be significantly faster with the same results at 56 milliseconds because it's using that index. Now, there are other types of operators. There's cosine distance as well. And cosine distance uses that less than equals greater than operator instead. It's a little bit different. And that, if you look at this query, it took 292 seconds to execute because it's not picking up the index. And I could show that by doing an explain plan on that again, and it'll use a sequential scan again, right? Because the other index that was created was only for Euclidean distance operator. So now I'm going to create an index on that same movie embedding table or column, sorry, and using the vector cosine ops, which is the index type used for cosine operator. If I run the query explain again, you see now it's using the index scan on movie embedding IDX1, which is the one for the cosine distance. And if you do the query, see the query performance, you can see now it's again now much quicker, 63 milliseconds, where it was took longer last time. And next is the negative inner product. And this is similar to Euclidean and cosine distance. And we don't really have time today to really kind of dig into why would you pick one over the other. But you can see that the operator is less than a pound sign, then or hash, and then greater than. And again, if you create an index for that operator, you get better performance. Before it's 297 milliseconds in the vector IP ops. A type was used for the negative inner product. And you can execute the query again and see that it's here in a second. We'll see, sorry, the first explain plan, and which I messed up right there. I meant to cancel that query, and then explain showing now it's using index scan on IDX2. And the query performance now, instead of being 300 milliseconds, now it's 57 milliseconds, very, very fast. So kind of a summary of that we kind of went over very, very quickly. The Euclidean distance index is different from the cosine versus negative inner product, and they all have different operators. So you have to make sure you're using the right operator for the index that you have in your database when you do these kind of similarity comparisons. The next part that I want to cover is similarity searches. So similarity searches like, well, actually, this is, I'm sorry, the store procedure that you can use to make it easier to do these similarity searches. And there's a parameter here for the type of operator, whether I want Euclidean distance, cosine, or defaulting to negative inner product. And it's using that same type embedding, and it's using that search query that you pass in to go get the embedding. And this is not required. It was makes it easier to consume this and not have the code sitting there and your Python code. But you can see that gets the embeddings for me, just show the capabilities of the Postgres creating store procedures or functions. So the movie summaries. So now this is there are multiple summaries in the reviews. So multiple reviews for the movie. So this is for Star Wars. I believe there are 6 total here, different reviews for the movie. So you oftentimes want to take like these kind of reviews and summarize it, right? Because you may have 6 rows, like in this example, you may have thousands of rows. It's like, I just want to kind of get an overview of my data, whether it be, you could do that for insurance or any kind of use case for any kind of your documentation and so forth. Give me a summary of all the data that I have available. So make it easier for me to understand. Like you see that on Amazon.com with reviews of products that we have listed on the website. But you can see there are 6 rows there, all the different movie reviews. So what I'm going to do is actually create a simple query that takes those multiple reviews and then store as one big column, and then pass that to Claude V2 to give me a summary of that text, right? So I took those 6 movies, turned that into one row, and it got a summary of that one particular movie of all of the reviews, right? So text includes reviews and reflections of the 1977 film Star Wars. That's groundbreaking cinematic experience, so forth, right? So it makes it very simple for you to create those summaries, all with SQL. So then again, I can create this as a store procedure. This is user-defined function where I'm passing in a movie ID and getting a summary of all the reviews. So it's the same SQL as before, but I'm now encapsulating that all in a user-defined function. So this is that same select for the Star Wars movie, passing over to Claude in real time to get the movie data or get the summary data from Claude V2. It takes about, this takes about 10 seconds, 14 seconds to execute, but it's the same result of the same, because the same input to the model. So to make this easier for us to visualize, let's move on to actually creating a Streamlit application. So this Streamlit application lets you type in search criteria that you're looking for a movie, comes out with the result of the most popular one, and then gives a summary of that popular one, and then the next 5 movies that are most similar to that. So to get this started, I have to install some Python packages, and so for time, that time waiting I edited that out, and then I can start the actual Streamlit application, which is pretty simple. It's just Streamlit run, and then there you can get the URL. In this case, we're using the external URL because it's on the internet. And here's a new start search for, in I think this case we're looking for lightsabers, right? Same as we were doing earlier, just inside the database with SQL code. So you can see their Star Wars movie came back rather quickly and is still running because it's getting that summary. It's in real time going over to Claude to give me a summary of this. And the operator here is Euclidean distance. And it shows you the top 5 movies. And notice the order of those, right? The Empire Strikes Back's number 2. The last one is Fanboys. But I changed the operator to cosine distance. I get the same result. Star Wars is number 1 again. But the next 5 movies are going to change order a little bit. And this is where, as like a developer, looking at your application and trying to understand what works best for you, you have these options within PG Vector to use different operators to get different similarity searches. And you can see this one, the negative inner product, which is kind of a combination of Euclidean distance and cosine, gets a different result, different top movie, and then it takes a little bit longer. There are more reviews for that movie to get a summary of that. But then it shows you the next 5 movies, and they're also in a different order, right? So again, you can play with that with your application to say which operator makes the most sense for what I'm trying to do. So it kind of poses some questions like, what did you notice that it ran a little bit slower, right? It's the reason why, because it was getting the movie summary dynamically. And notice the difference between the results with the different operators. And then you can improve performance by taking that summary and store that in a database, right? And so you could batch that up. And as you get summaries or new reviews of movies, you can update the database with new summaries of that, like in a separate offline thread. So that concludes the demo. I hope you really enjoyed that. I know it's fast and we don't have time to really cover everything associated with that, but I'm moving on to Ian, you're taking it from here, right?
Yeah, if you can share this deck, or do you want me to share the deck?
I can share the deck.
Okay, awesome.
That's right.
So if you would like to learn more, contact your account team or account SA. If you need a professional service or partners also, you can reach to them. AWS also provide the professional service to create this end-to-end pipeline. And we have already shared this link in the Chime chat. So if you want to run this workshop by your own, you can use that link. It's a public link. It's a self-paced and kind of immersion days, we called it. And yeah, John, moving to the next slide, please. Yeah, so I would request you to all please scan the QR code and provide us with your valuable feedback because this feedback is helpful for us to conduct future events also. And we really appreciate your participation. And if you have any Q&A, you can ask the questions now. You can unmute yourself, and we're happy to answer those questions. John, do you want to add anything?
I can show if anyone wants to. We have a little bit of time, I think. If you have any movie queries you want to suggest, we can try them out in real time. Because I did provision this workshop here, so I could go to it and we can do some queries if you'd like, or if you don't, that's fine too.
Yeah, if you want to showcase one sample, maybe John, like
Oh,
one big.
sure. So let's see, action comedy with car crashes. Crash was number one. And it's getting a summary right now. Um, and then the other movies: Collide, Car, Cop Car, Driver Baby, Final Destination. And let's change it to negative inner product. Looks like the same movie. Crash was number one again, and these movies changed a little bit. Well, I guess if there are no one asking for a particular query to search or try out in this application, I hope you do. Please, if you could fill out that survey, I'd love it if you could do that. Ian and I both could really um, would appreciate that. And Ian, you shared the link to the workshop itself, correct?
Yeah, that's correct, John. Yeah.
Okay. Well, if there are no questions, I guess that concludes today's webinar. Thank you so much for attending, and yeah, and thank you very much.
Thank you, everyone.